polynomials. So what's a polynomial again?
More than one monomial.
And how do I separate my monomials? By a plus or a minus sign, right? So we're going to do this. So, again, major concept for the rest of your mathematical lives, honestly. So, the biggest thing is you can only add, and we're going to put subtract here, but we're not going to subtract today. We're going to subtract tomorrow. But the same rules apply, basically. You can only add or subtract like terms. Now, we've talked about this, I think, before. What are like terms?
It'd be exactly the same.
Same variable with the same exponent.
Perfect. Exact same variable that has the exact same exponent. That's what like terms are. We've said this before. Right? So like terms, I said way back when, I think we said this before, we're going to take cows plus cows. We can only end up with cows. Right? So what you got to make sure of is that it's the exact same kind of cows. So here, if I have x plus x squared, these are still kind of cows, right? They're both x's. But notice that I have a squared and I don't have a squared. So realistically, this is a brown cow and this is a black cow, and we don't want them added together. All right, so they have to be exactly the same thing. All right, exactly. So how are we going to add? Or what do we add? What do you think? So, why we did what we did in those last problems for today's assignment, when we grouped them together, you can do that today, rewrite the problem and regroup them into like terms all the time, but realistically, how many of you are going to do that? Probably not very many, if any of you, right? Because it's just extra work. So, you can totally do that, but after you find your like terms, you are going to add, and then I'm going to put subtract again, because we're realistically going to do the same thing tomorrow. Add and subtract the coefficients of the like terms. So what's this mean? What are the coefficients?
The number in front of the variable.
The number in front of the variable. What's really important, again, is that the sign in front of each term is the sign for the term. I don't know if that makes sense. Let me read this again. Okay, it makes sense, but it's kind of confusing at the same time. So what I'm saying here is, even though that there's a sign right in front of it, the sign can represent two different things. It can represent if it's a positive or a negative sign, but it can also represent if it's an addition or subtraction sign. But if you consider it a subtraction sign, that subtraction sign is also a negative sign, and vice versa. That makes sense? So it's kind of confusing, but it really does make sense. All right? Now, what happens with everything else? So let's just say that I don't have like terms. They just get left out?
Well, like, they're already in the answer, like, to the side, basically.
You just throw them off to the side? Ah, the heck with you.
Well, use them, like, you wouldn't have or subtract them.
What was your question?
What happens if they're not like terms in the problem?
You can't add it. You just leave it as it is.
Alex was really right. I was just going to make it.
I
stumble through it. So realistically, if you have different terms, the problem could be the answer. So what I'm saying is, if you cannot add or subtract anything in the problem that they give you could actually be your answer. So sometimes you just might not be able to do anything. So if I have an X and a Y together that they ask me to add together, I can definitely not take an X and a Y. An X is a cow, a Y is a horse. I never want to add a cow and a horse together. So I just leave my cows and my horses separate. Yeah. So, what is this going to look like? This is going to look like this. All right. Oh, before we look at a problem, don't forget about your addition rules. Addition rules, we were talking way back when we were doing integers. What were my addition rules? If the signs are the same, we are going to add and what? Use that sign. Right? So if I have 3x plus 7x, they're both positive, I just add and use that sign. So 3 plus 7 is 10x, and I just do my addition. Same with negatives, right? So if I have negative 2x plus negative 6x, then I add and use that sign. So we get negative 8x. Right? The other version of this would be if my signs are different, right? What happens when my signs are different?
You have to make a number sign.
Okay, but what do you have to do first? You got to subtract them, right? First, so you're going to subtract and use the sign from what?
Bigger number.
Sign from, and we want to put it in quotations because why?
Because it's not necessarily the bigger number.
Negative or positive.
Yeah, because if it's a negative, the negative would really never be bigger. So we want to say what Addie just said, the absolute value, right? The greater absolute value if that's our bigger. But we all kind of know what we mean by the bigger one. All right? So, everybody remember those from way back when? That was a long time ago, right? But realistically, you've been kind of doing that all along with everything else. So here's my problems. And you get to decide kind of how you want to do this. So, first example. 9w minus 4 plus w plus 5. So first off, you notice this sign in between the parentheses. That basically tells you that it's an addition problem. Okay? So when we were talking about those last couple of problems that you did for today's assignment, remember how they asked you to regroup them in like terms? So you could rewrite the problem and you could group your like terms together. So if you wanted to do that, you could say 9w plus w. So I'm just putting my w's together, plus, and then I would have negative 4 plus 5. Now again, how many people are going to take the time to do that? Probably not a whole lot of you, right? So you can do that though, and then I'm just going to simplify. All right? So that would be one way of doing it. And basically then you don't have to rewrite the problem. So if you want to do that, totally up to you. Okay? Another way that I could do this. So this would be kind of like little number 1. Little number 2 would be I could do this vertically. Remember when you first learned how to add or subtract? They put numbers on top of each other. That's what vertically means. So I could say 9w minus 4. And then my plus sign is going to go over here. And then I'm going to put the second binomial underneath here. But I'm going to line up like terms. So I could put it vertically and put a w here plus 5. And then I'm just going to add up and down. So if you want to write the problem like that, you can totally do that too. And then I'm just looking at, remember, what's always in front of a variable? You can always put a 1 here, right? So now I'm going up and down. What's 9W plus 1W? 10W. Remember, anytime that I'm adding like terms, if I start out with a W, it has to end up a W. It doesn't turn into W squared. Okay? If it starts out, it's got to end with the same kind. Unless, unfortunately, it's subtraction and basically we kill them all off. Right? So if we have 9 whales and we subtract 9 whales, we kill off all the whales. There's no more whales left. You don't have to write 0 whales, right? They're gone.
Why whale?
Because it was a W.
Oh.
Why wouldn't it be whales? So what do I get here for my number? Plus 1. So if you like it vertically, do it vertically. Okay? If you like to put them in group the like terms, put them in group the like terms. Or 9W minus 4. If you can just do it, I would call this method right here horizontally. Because again, horizontally, I'm just writing it out as far as I can. But horizontally, to me, is just doing the problem like they give it to me. And so basically, I'm going down the line and looking at signs more than pluses or minuses. I'm not thinking about pluses and minuses as addition and subtraction. I'm always kind of thinking about addition. And then I'm just looking at this rule right here. If the signs are different, I'm going to subtract. So I'm always looking at the signs. So basically, I'm going to do it horizontally by saying I'm looking for all the W's. So what's 9W plus 1W? Then I get my 10W. And if I'm going to do horizontally, especially at the beginning, maybe I go back and I cross those out. So I know that I'm already done with my W's. And then I could just go back. I don't have any other variables. So then I'm going to look at my, what did I call the numbers? What was another name for just a number yesterday? A constant. Okay, so we might put the constants together, and -4 plus 1, as we already saw, was positive. Okay? Again, now, this isn't totally huge, but let's put a star at the end of this and say you want to write answers in descending, what's that mean again?
Going down.
Going down. Alphabetical order. So if you have different sets of variables, meaning if you have a K, a J, and a Q, I want to write them in order. Doesn't matter what the coefficient is, the number in front. I just want to go in alphabetical order. When it says descending order, remember that's talking about the same variables, so like the cousins. Okay? I would write the x squared term first and then the x term second, because it's descending order because x squared is bigger than x. And again, it doesn't matter what the coefficient is. Okay?
So that's your answer?
This is my answer, no matter what. So we didn't finish this one. So we would have got 10W and then plus 1 here. And we got that every which way. So I'm just showing you 3 different ways of doing the problem. You get to choose how you want to do it.
So are your answers always going to be equations?
Not equations. Thank you. Expressions? Yes. They should be. Maybe a number. Maybe a number. They're always going to be a polynomial. Usually a binomial, trinomial, but it could be a monomial. Okay, depending. Tomorrow it could be any kind, because tomorrow we're going to subtract. So obviously it's going to get smaller. Okay. All right. So again, now you get to decide what method you want to do. So here's my problem. 6x squared minus 3x plus 1 plus. Now, if you want to do it vertically, right here, if you want to do this method, then as I'm writing the second one down, you just write it underneath the part that you would match it up with. Okay, so realistically, you would see it in the book, and you would just rewrite it as you're writing it on your paper. But my problem is going to be x squared plus x minus 1. So, which way do you want to do it? Anybody want to group them together? Vertically? Probably going to come down to one of those two. but it's totally up to you. So, if you're gonna do it horizontally, I'm basically done. I'm just gonna go through and pick the ones that are the same. Alex said vertically, so I'm gonna take this second trinomial and put it under the like terms. So this is positive, and if you want to put 1x squared, remember we're adding. And then here's my x, but I have a positive 1x, and then I have a negative 1. So if you want to do it vertically, you can do it vertically. If you want to do it horizontally, you do it horizontally. That's totally up to you. But again, now, this right here to me is probably the easiest way to see it. But some of you are really lazy and you don't like to write the problem down in the first place, let alone writing the problem down more than one way. Not that I am pointing my finger at anybody. Alright? So, again, totally up to you how you're going to do the problem. Alright? If I do it vertically, to me, this is the easiest way visually to look at it, but that's totally up to you. So, if I go up and down, how many x squareds do I have? 7x squareds. How many x's do I have?
Negative 2.
-2x. But notice my variables always stay the same, right? And then what happens to my ones?
Cancel out.
They cancel out, so what's my answer?
7x squared minus 2x.
That's my answer. And again, notice it's in descending order, right? The biggest x comes first, and so on and so forth. It's not the biggest x by the coefficient, it's the biggest x by the exponent. Alright? Make sense?
Yep.
We need to do more?
Yes.
We're going to do more, but... Alright, so I want you to do this problem right here. 4x squared minus 3y squared. But you write it down on your paper however you want to do it. This one right here.
Oh.
So we're doing this problem right here. I want you to basically choose what method you want to do it as you're writing it down. Now, unfortunately, and I'm not trying to sound like I know everything, but to me, I probably wouldn't write a lot of these problems down because I'm so used to it. You know, I've done this for a long, long time. So when I'm doing this problem, I'm basically doing this version of it. I'm doing it horizontally because that's how they give it to me, but I'm just giving my answer as I'm looking at it. But again, you need to practice writing down the work. And so if you're going to do it horizontally, no big deal. You just write it back down. Is it hard for you guys to see through that loop?
No.
It is for me. I'm old though.
If there's nothing to go with one of them, like 4xy, you just leave it as it is.
Right on. Everybody hear what Grace asked?
Yes.
Okay? So basically, if you want to write it vertically, then above that you would have a what? Or below that? You'd have a 0. And if I add 0 to anything, what do I have? Whatever I started with, right? So again, that's where the vertical method kind of helps out. And again, if you do the vertical method, because it's addition, does it matter if I switch the problem and put this part on top? It doesn't matter, right? Today it doesn't matter because it's addition. Tomorrow it's going to matter a little bit. Because I can't just switch subtraction problems around whenever I want to. Because it's subtraction. Right? So here's the question. Which one's bigger between those two? Right? Because now I have an x and a y. So usually, when I'm talking descending order again, usually they're going to put the one that has both variables in the middle. But again, when we talk about descending order, you definitely do not have to ever write it like that. But when you get into algebra and you get into algebra 2 and those kind of things, you probably always want to write it in descending order, so we might as well get used to it. Okay? How'd we do? How'd I do? Did I get it right?
Yeah.
Yep.
Yeah? Anybody struggle with that one? Alright? But like Grace said, so this one didn't have a 4xy. So when I line them up, either on top or on the bottom, I'd have a 0, and if you want to put 0xy, that's fine. Or you can just put a big old 0, or you can just leave a big old blank in there. That's fine too. Okay? More? One more? Alright, let's do the bottom one. So the one right under the blue one. So if you don't have to do it, don't do this one, that's fine. How'd I do? How'd everybody else do?
Done.
So again, honestly, this version to me is probably the easiest. This right here is easy once you get the hang of it. But to me, especially then like Grace said, if I didn't, and I'm totally changing the problem here, but if I didn't have like 5x, I would just have either a gap there or I put a big 0 in there. And then I know that this other term would just come straight down. So again, to me, the vertical way is probably the easiest, especially at the beginning when you're getting the hang of it. But again, you guys, by the time you see me the next time in geometry, you won't even be writing this down. You'll just be doing the problem. Okay? In 3 years, that's probably okay. Questions here? How do we do? Make sense? So the biggest thing that you're going to slip up on is when you start going really fast by yourself, this is going to end up being 3 or 4 x to the 4th. Don't add your exponents together today. When it starts out as x squared, it's got to end up as x squared. Unless, again, we kill them all off. Okay?
I was gonna ask if that's what we're gonna do in subtracting.
We're going to do that tomorrow in subtracting. Yes.
How would 5x minus 2x equal 3? I mean 2.
He said he's just redoing.
I switched the problem. I took out my 5x.
Oh my bad.
To show you, kind of like this one back here. If I didn't have one of those terms, I was just showing you. I think I said that before. You know what's funny is you're the closest one to me. So you should hear me all the time.
I was looking.
I can talk louder if you need me to.